This question is from GATE Mechanical Engineering of 2021. This is question number 14 of set 1. The question is an infinite long pin fin attached to an isothermal hot surface transfers heat at a steady rate of Q1 to the ambient air. If the thermal conductivity of the fin material is doubled while keeping everything else constant, the rate of steady state heat transfer from the fin becomes Q2. The ratio of Q2 by Q1 is the rate of heat loss by long fin is given by Q is equal to square root of H P K A into theta naught. So this is rate of heat loss by long fin. Okay. Here in this equation, H is the heat transfer coefficient, P is the perimeter of the fin, K is the thermal conductivity of the material, A is the cross-sectional area, and theta naught is the temperature difference. So let's call this as QF, heat flow rate by long fin. So if all other parameters remain same, we can say this QF is directly proportional to square root of K, that is the thermal conductivity of the material. If let's write here, if all the parameter, other parameter remain same, and this condition is given in the problem. Okay, so now let's assume, let K1 be the thermal conductivity when the amount of heat loss is Q1. Okay, so when the heat loss is Q1, let's K1 be the thermal conductivity and K2 be the thermal conductivity when the heat loss is Q2. And according to the problem, K2 is equal to 2 times of K1, or let's write 2 times of K if K1 is equal to K. Okay, so this is the condition given in the problem. Alright. Now if we take the ratio from this equation, this QF is directly proportional to square root of the thermal conductivity of the material. So from here we can write Q1 is directly proportional to square root of K and Q2 is directly proportional to the square root of 2K. So if we take the ratio Q1 by Q2, we will get square root of K by 2K, or 1 by square root of 2. But in the problem it is asked we need to find Q2 by Q1, right? Q2 by Q1. So this will be equal to square root of 2. Now let's go back and match our answer with the given options. So we can see here option A is the correct choice. Now to see the derivation of this QF, you can refer to the NPTEL lecture number 36, Fin Heat Transfer 1 of Conduction and Radiation by Professor C. Balaji of the Department of Mechanical Engineering at IIT Madras.